Well, hello. It's noon, and it's Mass Timber webinar. So welcome everybody. Our topic today is new challenges in mass timber. It's a fascinating topic. Christman Construction and Nordic Structures come together today to share their experience from several collaborative mass timber projects, including the 8-story Apex Clean Energy Garrett Street project in Charlottesville, Virginia, and the state-of-the-art STEM facility at Michigan State University. They'll share lessons learned about site logistics, materials, sourcing, supply chain, integrating mass timber with other building systems, and protecting timber at the construction site. At any time during the presentation, if you have a question as an audience member, please type it into the Q&A. I'll be monitoring that, and when the presentation's complete, we'll get to as many of those questions as we possibly can. Renee, would you advance the slide? Couple logistic things. Please mute all of your lines, mute your video for some people's bandwidth, mute your audio if you can't mute the dog. And again, please submit questions in chats. Slide. So our sponsors today are the Michigan Forest Biomaterials Institute and Mass Timber at MSU. Mass Timber at MSU is a new initiative. It mobilizes education, science, outreach, and communication to advance mass timber construction and manufacture in Michigan and the surrounding region. It's a partnership with Michigan State University's Department of Forestry, its School of Planning, Design and Construction, and MSU Extension. MIFBI, the Michigan Forest Biomaterials Institute, fosters sustainable forests, communities, and economies through innovative and responsible production, use, and recycling of forest biomaterials. We are conveners and educators, we're independent and nonprofit, and we're volunteer driven. And I'm Brian Craig, by the way. I have a good fortune of being the board chair at MIFBI, and I'm an architect, who has designed and built projects in mass timber, and as an educator taught about mass timber. So this is a subject near and dear, and I look forward to the conversation today. Next slide. So with that, I'm going to turn it over to our presenters, both engineers. Andrew Riess is a senior estimator at Christman Constructors, and Eric Forget is a project manager at Nordic Structures. And with that, I'll turn the presentation over to them and rejoin at the end.
Thank you, Brian. Very happy to be here today. I'd like to thank the Michigan Forest Biomaterials Institute and MSU for inviting us to give this presentation. I've been to many of these presentations, and I've learned quite a bit, and I'm happy to be kind of passing on some of our knowledge to others. Eric.
Hi, everyone. Also happy to be here. Always happy to get back to talking about the MSU project. It was my first project at Nordic Structures, so it's always nice memories to bring back up.
Next slide, please. Today, Eric and I are going to talk about some of the lessons learned and some of the items that are a little bit different than normal construction that we've noticed on projects. Christman Constructors was the erector on both of these projects, and Nordic was obviously the supplier. These projects take a lot of coordination between the erector and the supplier, and some of what mass timber gives you is something a little bit different than the construction norms. things need to be done a little bit differently, care needs to be taken, and other items that make it a little bit unique. What we're going to go over today is kind of a list of some of these things. And hopefully we can shed some light on mass timber and how it can be effective, but items that you got to take care of when completing one of these projects. Next slide, please. The two projects we're going to go over today are the MSU STEM, which I'm sure everyone in Michigan's eager to hear about. It's a very unique project. It was transforming a 70-year-old old power plant into a student-ready maker and collaboration space. It had two wings, a north and a south side. Was integrating an existing 70-year-old structure, structural steel, and mass timber. So there's just some unique items, just integrating all those parts and pieces together. The Apex Clean Energy is a office building down in Charlottesville, Virginia, for Apex Clean Energy. They're a renewable energy company. This building was a pretty standard building as far as the shape and the dimensions. Had a concrete pedestal and then mass timber going up from the third floor up. Some of the unique items with this project were being in downtown Charlottesville. The site was very limited, so that brought a bunch of challenges to get that project built. Next slide, please. First, we want to kind of start off by giving you the pictures to kind of go over these projects before we start talking about them. I'm sure everybody's wants to see, how this progressed and what exactly it took. Next slide, please. The first one is the STEM building. This project was done at a site that had some room to complete the work. As we go on with this presentation, we'll explain to you how this site compared to the other site, the Nordic or the Apex site, how the amount of room we had presented challenges and how we had to kind of flip our plan to make make this project work on each of these sites. Next slide, please. The upper left, you can see where the mass timber is adjacent to the existing plant. Would you like to talk a little bit about some of the challenges, Eric, working next to that structure?
Sure. Well, basically, we had to attach to an existing structure. So some of the structural beams, as well as the structural panels, needed to be cut out and accommodate some openings in the existing wall of the power plant. Yeah, in regards to existing structures, installing the floor panels inside as well was quite a challenge for Nordic as for Christman Constructors, just because of the nature of the actual building.
Where you see on the Garrett Street project, the one we'll be looking at, it was pretty much just stack pieces and move your way up. The MSU job tying into an existing building, like Eric said, presented some challenges. On the picture on your right, at the bottom of the column, you will see some column protection that we will be talking about later. Just another one of the unique challenges that we'll be getting into. Next slide, please. And then here's our picture of our guys that constructed this project. It's always a good one to show everyone. Next slide. The Apex Clean Energy Garrett Street facility. Like I said before, this one was in Charlottesville, Virginia. Apex Clean Energy is a company that builds wind and solar projects around the country. This facility is going to be their new world headquarters, where they're going to house all their main company. This is a unique project in that it kind of gives a sustainable building system to a renewable company. So I think that's a pretty interesting kind of path they took. Next slide, please. This site had a lot of constraints. If you can kind of take a look at this picture here, you can see that this site had to be built in phases. The portion on your left is full height. That was phase one. While we were working on phase one, the portion right in front, the concrete contractor was still pouring the concrete decks. The site had a couple cranes that were swapped back and forth between the concrete contractor and us. So that kind of had some issues with our productivities and moving items around, moving timbers around. Also, there was some weather issues, which they don't quite often see down in Virginia. Next slide. Here's just a picture of about halfway up on the second phase. As I talk on more, we'll be talking about tying into other construction types. This project, we tied into the concrete core walls, which were the main bracing for the building. We'll get into tolerances and how you have to keep those in mind when planning out the job. Next slide. This picture here, we're swinging a CLT panel, floor panel. You can see below the concrete contractor working on, I do believe that is the third phase. So once again, we're working in tandem here on a very small site. So space and lay down room was a premium. Next slide. The four items that we're going to cover today are the site logistics, the supply chain, integration of timber to other building systems, and the protection of timber during the construction process, and also after we leave as an erector. Next slide. Site logistics. Logistics is important on any job, and it varies from job to job. In construction, you become a logistics expert. Every site that you go to, every project is different, and how you laid the job out, bring in materials, and build the job is different and is planned out before the job starts. On the two projects that we're reviewing today, MSU had room to lay material out to get it unloaded. On the Garrett Street, they actually had one of the public road lanes shut down for our staging of our material to bring in trucks to unload. So handling of the material and moving it around the site became an issue, and it was very time consuming, especially with the juggling of the cranes. You'd like to talk about logistics, Eric?
Yeah, just to add to what Andy just said in terms of logistics, we start discussing this as soon as we start on the project. So even when the project is still in the design phase, we're already looking at the logistics plan and site with the general contractor. With the CLT being stacked on our trailers, to erect directly from the trailers, we have to plan the space accordingly. Like Andy mentioned, you need the laydown area to prepare your material, but you also need an additional staging area for your trailers, depending on when the material comes into site and the speed of erection. So that's something that we always start planning a long time ahead of the first delivery to site.
Yeah, on the Garrett Street job, which pushed the logistics as far as our planning. The initial plan was to build the whole building, to erect the whole building at once. And during the pre-construction stage, it changed into phases. The CLT trailers that were supplied by Nordic were staged on site, so we could pick right off those trailers, keeping them in order, like Eric said, and pick them when we were ready. The glue lamp pieces would come on trailers, 20 to 25 members. They're wrapped together, so they need to be picked off the trailer, laid down. They need to be unwrapped, and that takes room. On the Garrett Street project, there was no room. We had a 2 to 3 hour window to get the glue lambs off the trucks for them to circle back. We actually used some of the concrete pedestal, the 3rd floor, and the floor we were working on as we were erecting up. Some of the issues with that were there just wasn't enough room, so we would have to take pieces, set them aside, then take those pieces, pick them back up, move them into place. So there was double handling of material that added time to the project and complexity. So when we came up with our initial plan, we had enough room to kind of lay these all the glue lamb members out. But with changes, the plan changed, and how we built the job had to change. So it's always, you always have to go in with a good plan. More planning means a better project, but that doesn't always mean that's how it's going to stay. With the MSU project, there was plenty of room for us to lay the glue lamb timbers out. One of the challenges there was that we were working off the ground. The site during some of the year was muddy. As everyone knows, these timbers are a finished project, so special care had to be taken to keep them in a good clean and state and not damage them. Unlike some of the other building materials, steel, handling it can be a lot, you can handle it a lot rougher. The timber, even though it's strong, it is delicate. The truck and trailer staging, as Eric mentioned, getting the pieces to come at the right time and getting them all staged right is vitally important. We'll get into the deliveries and everything, but with the limited room, if something's out of order, then we're doing multiple picks just to move members around to get them in the right order. So the Nordic team and the Christman team from our DC office work closely on getting everything tagged right and put in the right position to make the on-site erection go smoothly. The third item here is the crane location and type. This isn't really anything special to mass timber, but it is vitally important on any erection job. Getting the crane, a proper crane, to be productive and be safe is probably the biggest importance. One of your main differences with your mass timber is your multiple picks. When steel shows up, steel beam and trusses show up, most of the time those can be picked directly from the trailer, put in the place the trailer leaves. With mass timber, the glue lambs, you're going to be pulling them off, staging them. If you're moving them again and you can't get a smaller piece of equipment, you're doing an additional crane pick to separate them, and then you're doing your final pick. So you may have 1,200 members on a project or on a building, but your number of picks will be considerably more and a little bit more time. So that's one item that needs to be taken into consideration. Next slide, please. Supply chain. When I look at mass timber erection as a construction, I look at it as similar to steel. But going and looking at these sites and studying what happens on site, you see some distinct differences. The main one is the delivery distance and time. When you're looking at steel, you probably have a local fabricator, let's say within 150 miles, which is probably a 3 to 4 hour truck drive. With supply chain with Nordic, they're coming out of northern Quebec. The Apex project in Charlottesville, Virginia was a 1,150 mile truck drive. This project was completed during winter in northern Quebec, so there was weather that needed to be taken into consideration. Like I said before, Virginia got some snow, which they're not very used to. And unlike Michigan, 3 inches down there is basically stops everything. So that was something we had to take into consideration. We had to deal with a border crossing, and that was made harder by COVID, getting stuff over the border and getting it to the site. There are issues with deliveries if they're not taken care of right up front. You just can't go 150 miles down the road and get what you need. So Nordic has did a great job on planning it out, making sure all the pieces were there in order. There were a couple delays in trucks, but from almost 1,200 miles, that's understandable. But the truck showed up pretty consistent and with all the material we needed and all the material in order. So I'd like to comment on some of your supply chain issues, Eric.
Yeah, actually, to just put it into context a little bit for everyone, our factory is located 9 hours north of Montreal and Quebec. And so drive time to Lansing and to Charlottesville is about 20 hours from the factory, so 2 days. And like Andy was mentioning, we try to be as just in time as possible, especially for the Virginia project where there was basically no place to stage additional trailers on site. And obviously with the winter COVID, breakdown issues with the transporter, traffic that's unpredictable. It's not always easy to ship from northern Quebec to anywhere in the States and be on time. So that's something that we update with our erector. So in this case, Christman, multiple times a week to make sure that we're on schedule and they maintain their schedule as well.
When Nordic is shipping members to a job site, they obviously take a truck and they fill it up as much as possible. That's makes best economic sense for them. When the trucks are normally 46 to 65,000 pounds per truckload. Timber being lighter means that they can load the truck with more pieces. When you go to something like steel, which is about, I do believe, 10 times as heavy, there are less pieces. When the truck shows up on a steel job, like I said before, you take the pieces, you can put them up, unload them or pick them and set them in place. With the timber, we're looking at a lot more pieces that with the window we have to unload from the trucking company. There's a lot more pieces to deal with, so they need to be unloaded and staged so the truck can get down the road. So that was that's a big added time add to a project. And depending on the project, it can give you some problems with getting beams and columns laid out all over the place. Next slide, please. Integration of timber with other building systems. This is not anything new either. The MSU building was an existing concrete building with old tolerances and steel and timber. But they need to be taken into consideration during your planning, during the engineering time that Nordic does, to make sure that you don't run into any problems on site, especially due to where the factory is, and if anything has to change, how long it takes to get on the site. The 2-day drive right there can stop you in your tracks. Just to give you kind of an idea, concrete tolerances like on the Garrett Street, the shaft walls are about 1 inch and 100 feet. Masonry is about a ½ inch, where timber is a 1/16 inch tolerance. When you're erecting the beams, and it won't go in because the tower is out of tolerance and there's not enough room, it is possible to trim the end of the beams to make them fit. Obviously, if they've got to get longer, that is always a problem. So going out before the timbers come in, and doing your survey of the anchor bolts, doing your survey of any critical surfaces like an existing wall, a elevator shaft, or any other structures, is important to make sure that when the members start coming, that you're not going to be running into any issues, and anything that has to be taken care of or changed in the members, because that is not going to happen fast with the supply chain we just spoke about. Eric, why don't you talk about some of the integrating the building into the STEM building, the existing power plant?
Yeah, well, as I mentioned at the beginning, it was a challenge both for Christman and for Nordic, in the sense that we had to fabricate the panels to a certain size maximum for the erector to be able to bring the panels inside the building. In this case, Christman had to provide special rigging to move the members, so they had a hoist beam through the annex window in the back of the power plant to bring the panels in. And after that, we also had to be mindful of the weight of the pieces, because the erection team was actually carting the panels around on furniture dollies to be able to move them inside. And after that, they were handling them inside with chain falls that were used to hoist panels and that were moved around inside the power plant, depending on where we were in sequence in the installation. We also had limited as-built, since this building dates from the 1940s, and there wasn't a full survey that was done. So in certain areas, we had to refabricate a few pieces, because what we had on plan looked like what we had on site, but the measurements weren't exact. So we had to refabricate a few pieces. And one of the main challenges that we had to deal with is most of the steel structure, the existing steel structure in the power plant, needed to be shimmed with glulam shims in order to be able to install the CLT plumb and level inside the building. So that was a few weeks worth of work just there, separate from installing the panels inside the building.
Yeah, the buildings like the STEM building there's lots of challenges, lots of changes on the fly to make it work and to get it to tie into that existing building. The Garrett Street project, you know, in a perfect world, should go perfect. Everything should be built to tolerances, but anybody that's in construction knows that things happen, problems happen, and you try to work through them. But proper planning and checking your work before, checking your work during your QA/QC program. You try to avoid those problems, limit the problems, and keep the project on schedule. Next slide, please. The timber protection is probably one of the newest, one of the things kind of outside of the realm of what we're normally, what we normally do on a building type like this. When you do a steel structure, you put up the members. If it rains, it's no big deal. If it gets dirty, it's no big deal. The same with concrete. You're not really going to damage it too much during closeout construction with the mechanical, electrical guys, with carpentry putting in walls. When we got into mass timber and worked with Nordic, you quickly realize that these members going in are pretty much your final look, and are exposed. And that's kind of what you're paying for, is this unique look of timber. I always kind of put it in how mass timber construction works is kind of like building a house, building your first floor, putting in your drywall, and then when you're done with that, deciding to put the roof on. So you're putting in your finished product and it's completely exposed to the elements. I know on projects and listening to other people talk in the industry, there's some solutions that you're trying to come up to protect from weather. But there's other items that you have to worry about in the handling of the material, just getting it on site and laying it out, making sure it's cribbed up properly, so you're not damaging any of the surfaces. And then when it's in place, you got a lot of people doing a lot of work after you they need to be careful, or the members need to be protected so that the final product doesn't get damaged. The erection is probably the third trade on site, getting the building framing up. And then there's a whole bunch of trades and a whole bunch of time coming in after. So you're not really there to kind of box these guys out to make sure that they don't take a cart and ram it into a column or scratch something or do anything. Been on a construction site, things happen, and sometimes you just can't prevent them. So on the protection, like in one of the pictures and before, we actually provided the GC with actual wood protection, plywood protection around the columns. That way, when the trades were working on the floors, if they hit the column, which is probably your biggest issue, or if they're pouring the concrete topping, and then you get the splash up, the columns were protected. So when that plywood was taken off, you had a great clean surface. It takes a little bit to get the building protected, get the roof on, and get any type of glazing, siding, or any other exterior envelope systems up to keep the rain or snow off these projects. Part of our scope sometimes is to provide cleaning of the floors as we're erecting up, cleaning of them with water, cleaning them of snow or anything else on them. So we don't run into any staining or any damage to the wood. And predicting rain and snow can be very difficult, and how you actually kind of give them a budget to take care of that. So with that, like I said before, down in Virginia, they had a very tough winter, lots of snow, lots of rain, lots of ice actually. So we spent quite a bit of time keeping those floor surfaces clean. When you're inside one of those buildings and you're 2 floors below where they're erecting and it starts raining, it really doesn't matter that you're a few floors below. It's that water makes its way down through in between the CLT panels. And until you get that building envelope sealed, it's an exposure. Some of the other items, like I said before, is concrete. A lot of these CLT panels and the floors get a concrete topping. You're going to need to protect anything, any columns from concrete splash. It's a messy job putting that concrete in, so the concrete can get on there and actually kind of stain the timber, so you need to protect on that. And then construction itself is messy and dirty. The sites as they're being constructed, in the kind of the structural, in the beginning, the sites are usually dirt. The dirt can get tracked in real easy. It rains, the dirt starts washing down. So trying to keep it all, keep everything clean, keeping your housekeeping up is very important. And helps you in the end when the punch list items come and it's time to hand the building over, and the construction manager, the owner is expecting everything to look pristine because this is their finished product. So on final cleaning and punch list are kind of some open areas that we struggle with. The cleaning, like I said, they want everything to look pristine. We're handing the building over with the structure being up. I know Eric has to deal with some cleaning farther down the road, being the supplier. But you know, that's a lot of surface to kind of go over and make sure it looks perfect. A lot of times we're going in there if there is some damage to the column or beam, we'll go in there and do some repairs to those areas. Those all need to be kind of taken into account when you're looking at one of these projects, that you will spend time doing a little bit of cleaning, maybe trying to get some stains out if that happens, and then taking care of any little repairs. It's important to get the timber turned over to the CM and let them take care of anything that happens after you're off the job site. The MSU job was unique the way it was set up. We actually finished the project and then came back 12 months later to finish up our punch list, which is a long time to be hanging out on a project. So just make sure that these items, if you're bidding a job or if you're looking at a job, that these items here, they're all kind of extra work. Make sure they're either part of your scope or out of your scope, or you have some means of them to tell you to take care of it, and where you can get paid for it, because it can be a little bit of work and it can be a lot of work. It's a little open-ended. In general, it just as I put my presentation together and being in construction, I just not everything is negative. It started to sound that way to me. Construction is it's obviously building stuff, but in the management portion of it, it's solving a lot of problems. Looking at what you have, coming up with a solution, and working around the problems, because there's always problems. Every job, like I said, is different. You can look at it forever and you might miss something. So it's not all negative. The erection of the timber, I know we enjoy it, and working with Nordic has been great. Christman Constructors is very proud of these jobs. I consider them the best looking jobs during construction that I've ever seen. Being from a concrete and steel background, you look at a job and it's it's dull and it's gray. When you look at the Garrett Street project at night with lights on it, half built, and it's glowing light brown, it's a great sight to look at. So we're very proud of these jobs, and they've been very successful for us. As far as some of the benefits of timber, you know, as everybody's heard, the speed that these jobs can go up is a lot quicker, help you with your financial end. And then the great benefits are the looks and the sustainability. It's a very unique look. The Nordic is a renewable system. As they're cutting trees down, they are planting new trees to follow up behind. So it's a continuous circle for them, and that's a benefit that a lot of people are looking for. One of the other things that I see is I'm starting to hear of timber being mentioned in the same breath as other building systems like steel and concrete. You know, as everybody in the industry spreads the word, I see timber becoming more of a viable option, and spoken in the same terms as steel and concrete, which is great, and it'll give everyone here some more opportunities. Next slide, please. That's the end of what Eric and I had. I do again thank everyone for attending. I hope we helped you out a little bit, gave you a little bit of insight of what we deal with out on these projects, and be happy to field any questions.
Good stuff. And Andy, I'm so glad you returned to the positives in the end, because you all have lived, both of you and your companies have lived a lot of challenges, to make these things real, to make some of these ideas, somebody's dreams and desires real. So good stuff. We have a number of good questions. So I'm gonna go through them in the order received. Cool. And hopefully we'll get to as many as we can. Mm-hmm. I had some questions, but I'm going to put those off to one side for now. So first question from Eric Kehoe. Can you describe the challenges you see for developing more mass timber projects in Michigan? Supply chain issues, cost differences, and so on. I'm interested in developing a mass timber building through a more traditional private sector project.
I think that getting more mass timber buildings is going to take it's going to take some education. Getting architects, owners to realize, like I said, it's starting to be mentioned with as a viable building structure, but getting everyone educated on what's possible with mass timber, what the benefits other than the sustainability. How it saves money on schedule and other building costs. You know, it's a lighter material, you save on foundations. If it's exposed, you save on a bunch of interiors. There's been lots of presentations and seminars that I've sat through, and I'm sure a lot of people have sat through, that look at the cost benefits. And I think Eric might want to talk about how getting the mass timber supplier integrated early will help keep the budget in check.
Yeah, budgeting check, column sizing, beam sizing, slab sizing, connections. So basically, the cost difference is mostly in optimizing your grid lines and your spans. To a certain point, mass timber will be a little more expensive than concrete or steel for the equivalent building. But as you optimize your spans and everything, you can pretty much break even in terms of just the structure. And then, as you mentioned, Andy, already, you save costs on erection, you save costs on materials, And a lot of what we've had as feedback of clients that have built mass timber buildings is they recoup the cost multiple times because people are willing to pay more for their rent or purchase cost because of the exposed mass timber, because of what it brings to their environment, and just for the look, basically. So in terms of cost difference, currently, I think that's mostly why we don't see as much. Just need to get people to understand that it's still worth it, and obviously it's sustainable. So for the future of our planet, it's a good way to go.
I want to add a very specific Michigan challenge, and that's our building code. So if you're considering a project in Michigan, talk to your architect, engineer, designers about our building code. Michigan has a process by which it adopts codes that, and as a matter of course, we are on the 2015 edition of the International Building Code. So newer code iterations have more accommodation of mass timber, particularly in tall buildings, but more accommodation of mass timber. We, MIFBI, Mass Timber and MSU, others are working with our regulatory agency and the legislature to see if we can accelerate the specific adoption of the specific things around mass timber. Because as a private sector person who asked the question, your constraints are a little different than a public client such as Michigan State University. Another question. How much quicker has the schedule been with erecting mass timber structure compared to concrete and steel? Although more picks are necessary, it's my understanding structure can go up much faster.
Well, that's a good question. Relatively, I've heard 20%, but that's where the planning comes in, and working with the construction manager and with Nordic. Once you take a plan, optimize your plan, and change it, that's when additional picks come into place. So coming up with a plan at the beginning, optimizing it, is really where you're going to save time and money. A lot of issues that we had on the Apex job were due to a change in plan. You're also going to save time on your finishes if you're going with more of an exposed look. You know, you're not going to be running as much drywall and ceiling, and that really depends on your time savings there. It really depends on you know, what you're reducing in that scope. There have been many studies on the time savings. I've seen on a building of a month to 2 month savings, and some examples. Which one thing it does is it lowers your construction management time. So there's lots of factors. Woodworks.org has a lot of information on the savings, possible savings, and the changes from a regular conventional building to a mass timber building.
Right. And by the way, if I don't give the questioner's name, it's because as they come up on the Q&A screen, some have names, some say anonymous. So we'll identify you if you're not anonymous. So another question, how do the MEP trades do working with mass timber construction? Do these trades have any issues with the construction method?
It comes really the responsibility of the designer of the building. To kind of coordinate the design, and then coordinate with the building, like Nordic material supplier, to accommodate, like you would in any building, how those trades go in. The pre-planning, chaseways stuff, getting items like that into your building is pretty much the same as any other building. There are some tricks and trades, tricks that I've seen to kind of integrate that stuff into the timber and penetrate some of the beams to make it kind of the industrial timber kind of looking thing. But other, you know, once you get the building up, it's just should be like any other building.
Right.
Yeah, if I can add to that, Andy, if it's coordinated in advance, we can prefabricate most of the runways, the penetrations through the CLT slabs, which is different than concrete and steel. Concrete, you have to sleeve everything before you pour your slab. So yeah, that's something that can be prefabricated at the factory as well on a CNC machine. So it's cleaner, it's quicker, and yeah.
We continue. There continue to be questions about the process of protection and enclosure. The question is, here's a question: is there a need to provide a temporary envelope of enclosure, temporary roof or walls or whatever, to ensure that the structure is not damaged in weather, or can it just be maintained by cleaning and so
on? That can be provided. The jobs that we completed, they weren't a requirement of the project. I'm seeing more and more it either being kind of pushed on us or another contractor or somebody else coming in and putting an envelope on to protect it from the rain. The different types of cross-laminated timber are affected a little bit differently by the weather. So depending on what it is, what you're using, you might have a little bit more issues. You might want to take some more care, but it really comes down to what does the owner want to pay for?
Right.
So the answer is it's not required. Nordic as a manufacturer, if it's possible in the construction sequence, we strongly recommend that the envelope follow the erection of the building. And obviously you will want to put your roof membrane as soon as possible. And then I saw another question, and I can actually answer that at the same time. The wood species that we use is black spruce. It's extremely dense and not very sensitive to water absorption. So it can be left to weather for a long time. The only thing that's going to happen is basically the color of the wood is going to change a little bit with exposition to UV rays and rain, snow, and whatnot, but it will not damage the structure or the wood per se.
I'll jump to that because there's a second part to that question, which is use of more hardwoods in mass timber in Michigan. And this is a Michigan question because we have abundant hardwoods, but probably not as abundant black spruce. So what are you, and we know, and we've had presentations and we will continue to have webinars on hardwood and mass timber, but from your points of view, are there possibilities with hardwoods?
I think that's for you, Eric. I know Nordic is set up to do, they're one type of black spruce, and they have their facility is located near the source of the material.
Right.
I think if anything is going to be around Michigan, I don't know how the economics would work of taking the timbers and taking them to a manufacturer. That'd be something that would have to be studied to see if
right.
If those woods could
be
used.
We do have a certain percentage of pine that gets thrown into the mix of the black spruce, but the reason why we use black spruce is for the mechanical properties. So it's a lot sturdier in terms of bending, shear. We can generally get away with smaller section sizes for the same load resistance with black spruce than we could with other species. So that's pretty much why we use that specific species, plus the fact that it's very readily available in northern Canada and the boreal forest. So those are two of the reasons. And other than that, it's a fairly long growth tree, which is why it's so dense and hard. And yeah, that's why we mainly use black spruce.
Thank you. There have been several questions on cost, and we talked about it briefly before we came online here. The short answer is it depends. Is there anything you can say to our questioners about relative cost compared to concrete or steel? Without another webinar.
Yeah, well, Andy, if you mentioned woodworks, but basically there was a very extensive analysis done by, was it KLNA and Woodworks, in regards to, like I was explaining earlier, the spans, and basically depending on what span you have, so your bays and your grid line dimensions, at a certain point, it gets less costly to use mass timber than to use steel and concrete for multiple reasons that we've already mentioned. So yeah, there is a pretty extensive analysis that was done on that, and that's that should be relatively easy to find online.
Also, I've looked at quite a few projects where the timber supplier was not part of the initial design phase, and some of the details and what they were looking to do really was not very economical. Getting somebody like Nordic integrated before, so they can kind of hash out the best details, the most economic details, the most economic way to frame and erect the building will greatly reduce, relatively reduce the cost of your structure. I've seen buildings that have been designed that aren't viable because of the way they were designed.
Yeah, and just speaking for Nordic, like I was explaining, we have a proprietary grade of mass timber as well that is a lot more load resistant than others. So when we're brought in early, we usually try to optimize the sections to our standard sections to avoid material waste, and basically to lower the total volume on the project, which eventually lowers the cost in the end for the client.
So I'm gonna make a last question, because this is a great segue into the project team. And implicit or mentioned in your presentation have been sequence of when team members are engaged, as well as the architect, the engineer, the owner, yourselves as providers and fabricators, a construction manager. What does the use of mass timber do, or what does it recommend for the sequence, how the team comes together?
So at this point in the life of mass timber in terms of the structural material, generally we strongly recommend to our clients to bring us on board early, because not a lot of engineers and architects have worked with mass timber up to now, and they're not always aware of how it goes together, how you design connections for mass timber, and like I was saying, in terms of us being a fabricator and supplier, we can optimize the section sizes to reduce the total volume of the project to save on costs, and we can guide the clients in terms of the typical details for connections and fasteners and stuff like that. That optimizes the cost of the project for the client in the end, versus if we were brought on board when the construction documents were 100% out.
And I see on our Q&A there are a couple questions, and we're going to leave those unanswered specifically, though they've been addressed, because we're getting very close to the end of our time here. I guess I'd ask both of you, Andy and Eric, do you have any last counsel, any comment you'd like to make?
No, I just appreciate the opportunity to speak to everyone. It's been enjoyable, and if anybody has any questions, they can reach out to Christman Constructors and track me down, and feel free to ask me any other questions that you want.
All right, thank you.
Yeah, I'll pretty much err in the same direction as Andy. If anything, our website is easily available. and you can send any questions to our information email. We'll be happy to follow up and answer.
Great. Well, thank you. And thank you both. This is really good stuff. I mean, you know, you're doing some really hard work that in a sense is the unseen part of delivering projects. You know, there's a vision, there's an idea, there's a visual, there's a place that comes from it. But thank you for all the work you do in bringing this together, because that's tough stuff, and it's really important stuff.
Thank you.
So thank you again. And the recording of this will be available both through MIFBI's website and through Mass Timber at MSU. And I believe a link will be emailed to attendees or to those who are registered if you'd like to see it. And with that, and that, oh, by the way, it'll probably be early next week when that goes online, the video. So with that, thank you, and we look forward to seeing you again soon, and look for the notice of our next webinar soon to come. Thank you.